So in the previous video, we understood the complex solutions of cos theta, and now we're going to do the same exercise but for sine theta. Okay, so what we're going to do is we're going to look at these four things here: sine theta equals a, sine theta equals minus a, sine theta equals ai, and sine theta equals minus ai for a greater than 1. So we're looking at complex solutions, and these are the four solutions which have been mixed up, and the trick is to find out which one of these corresponds to which one of these. Okay, so I'd strongly recommend that you have a look at the previous video first, because I'm going to go through these a bit quicker, because a lot of what we've already done, we've done in the previous video, and so there's no point reinventing the wheel. Now, just to have a look at, if we look at Euler's identity, we got that e to the I theta is cos theta add I sine theta, and e to the minus I theta is cos theta minus I sine theta, and adding those up gave us what we were using yesterday, which was cos theta equals e to the I theta add e to the minus I theta over 2. Well, if we take them away, we get that sine theta is e to the I theta minus e to the minus I theta over 2i, and that I does make a difference. Okay, so we're going to use this to solve these and work out which one is which. So let's have a look. So let's start with sine theta equals a. That's the first one. How are we going to solve that? Okay, so we got that e to the I theta minus e to the minus I theta equals 2ai. That's from there. And then we form exactly the same as the previous video. We form a quadratic in e to the I theta, so e to the I theta squared minus 2ai e to the I theta minus 1 this time. That is a difference from cos as well, and therefore we have that e to the I theta. We're going to solve that using the quadratic formula. So that's e to the I theta equals minus b, and there's b, so that's 2ai plus or minus the square root of b squared. And we have to be careful again with b squared. The previous video, exactly the same problem. That is minus 4a squared minus 4ac, which is add 4 all over 2a. And that equals ai plus or minus I root a squared minus 1. Okay, so we've got that. Now, as a, well, we can take the I out here, which equals a plus or minus root a squared minus 1. And we've had this discussion in the previous video, whether or not we take the I out. Because a is always greater than root a squared minus 1, we can quite happily take the I out. So now, taking logs, we have that I theta equals log of I add log of a plus or minus root a squared minus 1. Again, fairly similar to the previous video. And then now we've already done that log I is equal to pi I over 2. And therefore, when we put the pi I over 2 here and then divide by I, that gives us that theta equals pi over 2 minus I log a plus or minus root a squared minus 1. And that is our first solution for when sine theta equals a. Okay, so now let's move on to the next one, which is sine theta equals minus a, and you will see there's some fairly good similarities here. So we have therefore that e to the I theta minus e to the minus I theta equals minus 2ai now. So therefore, again, forming our quadratic, exactly the same, e to the I theta squared add 2ai e to the I theta minus 1 equals 0. Solving it with our quadratic formula, we get e to the I theta equals minus 2ai plus or minus, exactly the same, minus 4a squared add 4 over 2, which simplifies to minus ai plus or minus I root a squared minus 1. And again here we can take out the, well, this time we're going to take out minus I, so that equals minus I a plus or minus root a squared minus 1. And then what we do is we take logs again. That gives us I theta equals log of minus I add log of a plus or minus root a squared minus 1. And again, if I'm going too quick here, have a look at the previous video where we did the equivalent for coses, where we go through it much slower. Now the log of minus I, as we did in the previous video, is 3 pi I over 2. So therefore we have that theta equals 3 pi over 2 minus I log a plus or minus root a squared minus 1. And that one there is our solution to sine theta equals minus a. Okay, so we're moving along these ones quite nicely. Now let's have a look at the third one. The third one is sine theta equals, what's the third one? Oh yeah, ai. So this is the third one, sine theta equals ai. So again, we have e to the I pi theta minus e to the minus I theta over 2i. And let's do this slightly slower because there's an I here, equals ai. So then when we multiply, we get e to the I theta minus e to the minus I theta equals 2i times ai. Well, I squared is minus 1, so that gives us minus 2a. And therefore, forming our quadratic, we get e to the I theta squared, add 2a e to the I theta minus 1 equals 0. Solving this, we get e to the I theta equals minus 2a plus or minus the square root of 4a squared add 4 over 2, which simplifies to minus a plus or minus the square root of a squared plus 1. Now, because a squared plus 1 can be greater than a, we have to split this into 2, same as the previous video. We get e to the I theta equals, we either take minus 1 out, which will be a plus root a squared add 1, and the other solution, and e to the I theta is minus a plus root a squared plus 1. So they are the two splitting of that, and therefore this gives us that I theta is equal to log of minus 1 add log of a add root a squared add 1. That's the first one. And I theta equals log of minus a add root a squared add 1. And so therefore our two solutions here are theta equals log of minus 1. Again, we did this in the previous video, is pi I, and so therefore when we divide it by I, we get pi minus I log a add root a squared plus 1, and theta equals minus I log minus a add root a squared plus 1. And these two here, let me just check them, they are correct, yep, are the solutions to sine theta equals ai, and all we got to do now is the fourth one, sine theta equals minus ai. Now this is very similar, so we can jump straight through the quadratic. E to the I theta squared minus 2a e to the I theta, that's the only difference, minus 1 equals 0. So therefore e to the I theta equals 2a plus or minus the square root of 4a squared add 4 over 2, which equals a plus or minus root a squared add 1, same as before. So again, we have to split because a squared plus 1 square root can be greater than a, and so therefore we split it into e to the I theta equals a plus root a squared plus 1, or e to the I theta equals minus 1 times minus a add root a squared plus 1, which solves our negative problem. And therefore from these two we get that so we get that I theta equals log of a add root a squared add 1, or I theta equals log of minus 1 add log of minus a add root a squared plus 1. And therefore our two solutions here are theta equals minus I log a add root a squared add 1, or and theta equals, well, a log of minus 1, again we just done that up there, is pi minus I log minus a add root a squared add 1. And they are the two solutions to sine theta equals minus ai. So you can see, in actual fact, once we've got the hang of this, they're relatively easy to derive, these solutions for sine and cos. Now what we're going to do in the third video, which is the climax of the whole thing, we are going to use the results on sine and cos that we've just found to prove or to show that cos squared theta and sine squared theta equals 1, even in the complex domain, even though it may not look like it from some of these initial results here. So look out for that. I hope you found this useful. If you have, please press the little thumbs up button and subscribe to the Gresty Academy YouTube channel. Thank you.